The title of this talk is Windows Operating System Archaeology. This is, we're going to be covering some things that have been in Windows since the beginning of Windows. We hope you'll find it very interesting. We hope to spur on additional research from the community. So my name is Casey Smith. I'm Director of Applied Research at Red Canary, and you can find me on Twitter at @SubT, or there's my blog URL. So.
Yep, and I'm Matt. I'm a senior operator and security researcher at SpectreOps, and then you can find my blog and hit me up on Twitter as well if you need to.
Cool. Okay, so what we hope to get out of this talk would be, again, foster curiosity. We really believe that research and looking into things really is driven by curiosity. Like, if you want to go learn something or find out how something works or find a new bypass, it's really on you to have the energy and curiosity to sustain that search. So hopefully this will also spawn further research, get people looking at more people looking at COM and some of the things we're going to talk about today. We've got extensive references on our Git repo, so you don't have to take pictures of the slides. They're all on the Git repo. We'll talk about at the end. We've got plenty of examples, and again, we want to really call attention to the attack surface that COM provides. So COM is a rich target, attack surface. So we want to make sure you guys are aware of that. There's very few products that have visibility into some of the things we're going to show you today. So we really want to drive innovation in not only attacker methodology, but also detection capability. So first of all, we're going to go over what COM is. So the component object model, we're going to give you a brief background just so you understand when we start doing things like COM hijacks and persistence and bypassing, we need to have some of the fundamentals so everybody's on the same page as what's actually happening. We'll talk about a couple things with COM. Registration and resolution are the two main things we're going to focus on. So how does a COM object get registered? And how does a COM object get resolved when the operating system wants to go find something? And that's where there's a lot of fun things because, as Matt will show you, there's plenty of things that are being looked for that are not there, and we can supply those happily to the operating system. So we'll go over a lot of those. How many of you have heard of COM? Has everybody at least heard it? All right, awesome. Great. How many of you have developed in COM?
I'm so sorry.
Your hands. Okay, some of you. Okay. So what a COM object is, or the component object model, think of this as it was sort of, it was before .NET, and it was sort of a cross-language way to share binary data. And so you could build these COM objects in things like DLLs, you can put them in EXEs, you can put them in OCX files. Some of the more recent things that we found and what we use for a lot of our proof of concepts are these files called Scriptlets, or Windows Script Components, or SCT files. So hopefully everybody has at least heard of these. They got a lot of attention last spring with some Red Surf 32 things we'll talk about. But these are like, an XML file was attractive to me because the environment I was working in was a whitelisting environment. So dropping an EXE or loading a DLL just was not even an option. Whereas dropping an XML file and running something in memory suddenly became really, really interesting. And so we'll talk about that. And then COM has this idea of location transparency. And so, you can create objects on other machines, you can create objects in other processes. It's really pretty fascinating, and I think Matt's lateral movement stuff he's going to go over today is going to be, sort of examples of using that location transparency. Hey, I want to create this object on another user's machine. Really pretty cool stuff. All right, let's see. Okay, so I wanted to give you at least an example of a COM script because, like I said, we use these for our proof of concepts all the time. So think of this as a COM object backed by XML. And so you have the XML tags, you have a scriptlet tag, beginning and end tag like HTML, basically. You have a registration block for the object. Inside of that registration block, there's going to be some various properties that you're going to set. So pro tip for defenders, attackers rarely change the class ID that I made up that has the feed ACDC string in there. So if you're watching for stuff, just look for that. They run it right off Git repo. So the other thing is then you have the code contained inside of this registration block, which is a really interesting capability. So this gives us the ability when you go to register a COM object or unregister one, whatever's in that block of code will be executed. So the trick with COM is sometimes unregistering an object is just as interesting as trying to register one because you can get code execution in that path. So that's a COM object. Just wanted to make sure, our COM scriptlet, just want to make sure everybody understands what these are when you look at this POCs and we start downloading and executing COM scriptlets. We're going to pop calc. We were trying to count how many times calc appeared in the presentation. I think we were up to 9 or something like that. But anyway, that's what a COM scriptlet is. So. Okay, so registration. So I talked about two things that are important with COM. First is registration, and then the second will be resolution. So a COM object is registered And it sets itself up in the registry, and there's multiple hives or keys that are going to be set up. There's HKey current user, HKey local machine, and there's HKey current root or class root. And that one is kind of interesting because it's really a hybrid of those two. It's kind of a virtual directory. It doesn't actually exist. It's read and processed and presented as though it's its own key, but or hive, it's not. So generally speaking, you're going to find COM objects in the registry, and generally speaking, when the operating system wants to create a COM object to like display thumbnails when you open up Explorer, I mean, there's all kinds of uses for these things. It's going to look to the registry to find the instructions on where that object is defined and then carry out the task. Okay, so except for when you run into registration-free COM, which came out with like Windows XP, and we'll talk about how that can be abused as well. So generally speaking, COM objects live, they're defined inside of the registry. I mean, that's the main thing to take away. So there's a search hierarchy that we'll get into now with resolution that's important. So when you go looking for a COM object, I can go to the next slide. Yep. Oh yeah, this is just an example. So you're seeing in this example in the registry, you see a class ID, which is a hexadecimal value here, and then you see multiple subkeys. This one we just found was a pretty good example of having multiple keys. Some of these are really going to be interesting. In particular, we'll talk about this one called treat as, which lets you reference another COM object. So you can say, oh, this object is really actually over here at another location. That becomes really important when you're intercepting or tampering with the resolution process. So it's a legitimate key, but it's very often used for abuse and COM hijacks. So that's all you'll see. You'll see literally, I think we enumerated just before this, like 7,000 COM objects in Windows 10. So just a few places to hide. So, all right. So as far as resolution, some terms you need to know. The class ID is a GUID, whatever you want to say. A prog ID is a string, like a friendly name to refer to that application. So excel.application or word.document. Those are just ways to refer to the COM object in a friendly way. What's really interesting, though, are these things called monikers. And monikers are a way that are installed on the system to resolve a COM object. So one that we use a lot is this Scriptlet Moniker. And if you look closely at that, it looks like a URL, but it's prefixed with Scriptlet : or you'll sometimes see script : And what happens is that when the system goes to resolve that, it will say, oh, I need to go out to the internet and pull this definition for that COM object down, and then either register or execute it. So we've seen this in the wild. I think if you look at the code on the bottom here, you see this is like the Powellix malware command execution string where they're calling get object and they're using run DLL32 from a command line, but the object they're passing in is a Scriptlet : URL. So those of you doing defense, defenders looking at that, sometimes you can go grab their payload and look at what the second stage was. If it gets dropped, it's going to actually drop to the temporary internet file. So it doesn't live just in memory. These do often get written to disk, depending on how they're downloaded. So a couple things to keep in mind, but get object and create object are fascinating because they'll do this resolution for you dynamically. So if you have a proxy, SSL, if you use a URL shortener, it'll follow redirects, it'll run SSL, it'll authenticate to your proxy and resolve that object dynamically. It's really fascinating. So we use get object quite a bit. Okay. So here's some examples. So WMI, for example, has a moniker that you could instantiate. You can call, this is VBS. So you can say get object with the win management, which is the WMI, and then you can say schedule tasks. So you can then enumerate scheduled tasks, or you can set some impersonation or authentication levels with these monikers. So just pointing out that the get object function takes inside of it typically something that's referenced by moniker, and that becomes important. Does that make sense? Okay. Awesome. So we found this one last night. This is really cool. So get object is referenced in all sorts of different paths. And so we found this PowerShell, or it's really a .NET method called Interop Services Marshal, and it has this function called bind to moniker. So this is kind of fun. So you can just actually pass it a scriptlet and get it to execute something. Now, most people are like, well, what? That's really not interesting. Where do you execute? Well, we decided to execute Mimikatz, and that all of a sudden becomes really interesting because now we can reach out and pull an XML file that has Mimikatz embedded in it and get it to execute on the system. So that's pretty fun stuff. This bypassed at least AMSI and something else we were talking about. The
PowerShell logging?
PowerShell logging, yeah.
You won't see the output of Mimikatz in the log anywhere.
Yeah. Question here.
XML extension. need to be?
Oh, great question. Yeah, so the question was, does the extension like WSC or XML, it can be whatever you want. JPEG, PNG, doesn't matter. It's the contents of the file that are important. Does that make sense? So the question was, does the file extension matter? Doesn't matter at all. It can be anything. So really good question. So yeah, so we like this because then we could use PowerShell. And if PowerShell's on with logging, then we can just jump out of it, and our output and input is no longer logged by PowerShell because we're running in this COM object. So pretty fascinating. Or here's another way to do it. So make PowerShell VB again. Why in the world would you do that? Well, again, because of logging. And Dave talked about that this morning, how PowerShell, very strong language for defenders to get telemetry, to understand what tradecraft you're using. So trying to innovate and look for ways where we can stay out of the log lens. So this is, again, just another way to call get object in PowerShell, your output and input that is no longer visible in the logs. Pretty cool.
Yep. There you go. So speaking of Visual Basic or Vbscript, this is kind of an undocumented COM object in Windows, a scripting.encoder one. More or less, it lets you take Vbscript or JScript as input, and then it encodes it in some really obscure, not documented, random encoding scheme, and then spits it out to you in a way that Vbscript or JScript can interpret it. So this is just an example of using this. This is just a simple Vbscript that starts calc via the Wscript shell COM object. We run it through the encoder, which exists by default on Windows, and then spits this file out to you, which is useful. You can run that Vbscript that's generated, and it will execute. What's neat is in these COM scriptlets, you can actually set the language type to Vbscript.encode, meaning that it's going to instead of taking Vbscript or JScript directly, it's going to take the encoded blob and it's going to interpret that for you. So you can take your COM scriptlet, encode it via this object, and then throw it in your actual payload, and it's going to be. I put out kind of a teaser tweet, and a lot of people were like, "How do you decode this?" There are a few tools that don't do it 100%. There's one script that Microsoft put out a really long time ago on decoding VBE, and it's 3 lines to encode it, and it's like 30-something lines of Vbscript to decode it, and it's not always super accurate, and it can get really funky. So this is just kind of a cool little offensive tip, and then for defenders, something to keep an eye on.
Yeah, so one of the things a lot of defenders are doing these days is decoding your encoded PowerShell, right? So they see your encoded command, they decode that. Even if you've done it a couple of layers, they iterate through, and it's automated in their defense system. So again, we were trying to find ways to avoid or raise the, they're always talking about raising the cost for attackers, but we like to sometimes raise the cost for defenders. It makes us all better. So, okay, cool. Okay, so normally when you register, so again, we talked about registration and resolution. There's some built-in tools that actually will handle COM registration for you, and these are run all the time, or very often. I shouldn't say all the time. But there's Reg SVR32, Reg ASM, and Reg SVCS. These are the last two are .NET tools. So if you write a COM object or write a class in C#, you can register it so it's available to applications like JScript or Vbscript. But that's normally how you're going to see a developer that wants to publish a COM object register that. They may do it directly in the registry, but it would be more likely to use one of these tools to pass in the DLL to get registered. So something to be looking out for these tools, and these are known whitelisting bypass tools because you can inject into the registration process and get code execution. So I don't want to go over every point on this slide, but I wanted to make sure you understand. This is actually from the COM specification. How many of you have read this from 1995? It's great stuff. All right, a couple hands showed up. It's a really good read, gripping. But inside of here, what I wanted to point out was the sequence that happens when Windows goes to locate an object. It's first going to look up a call to get class object, then it's going to go look in the registry, find the DLL or scriptlet, whatever's backing that COM object, load that into memory, resolve the class, and then make the object available to the application. So we don't necessarily have to go through every step here, but I wanted you to see there's a sequence. Probably the most important thing is go check the registry first, see where the definition is, and go look in sometimes HKLM, go look in HKCU. We'll get into that sequence hijacking a little bit later, but there's a process to find and execute that COM object. Load the DLL or load the scriptlet. So, awesome. So again, what does this mean? Most of the time you're going to find the COM artifacts, if you're doing forensics or investigations, in the registry. Most of the time. So we don't like to live in the registry. We like to find places where we can execute things outside of that. So let's talk about registration-free COM. And so how many of you have heard of this before? Registration free com? Not many people, okay? So the idea here is there's a class available to you called the Activation Context class, and it actually lets you provide a manifest that defines where the definition for this COM object lives, what DLL, and when the application runs, it looks to that manifest first as opposed to actually looking in the registry. So the idea was, if I want to deploy a COM application, have it be self-contained in a directory or a zip file or something that I can easily deploy, this made it easy. The problem is there's no artifact or no registration in the registry keys that define where that is. You have to actually capture that binary and the manifest file. And the manifest can point to a URL. So that gets even more interesting. So if you want to learn more about registration free com, I've done some examples on my Git repo. You can check those out, just loading DLLs from manifests. So anyway, just want to make sure you're aware of this. How many of you saw James Forshaw's talk at DerbyCon this year? Anybody see this? A couple of you did. So it's out. All those talks are published like within an hour or so of being. It's amazing what they do. So the video's out there, but I encourage you to check this out. But he used the activation context to also create and load this class called Microsoft Visual Basic Devices Computer, and it's got some really interesting things that it can do, like send keys, gather stuff off the clipboard, and all that's like that's not exploit. It's just built-in functionality for that class. So some really good examples. Again, he's released his slides and all of his code samples, so I encourage you to check that out if you want to dive deeper into some registration-free COM. Activation Context, or ACT CTX, is a really interesting COM class. So, how many of you have heard of .NET to JScript? A couple of you. Okay, this is really important. Why I wanted to make sure this makes it in here. So, historically, you didn't really use Vbscript or JScript because you couldn't make Win32 API calls. I mean, there's only so much you could do. Really, you're kind of in a sandbox, right? Like now with .NET to JScript, what James Forshaw published was the ability to take the .NET assembly, and .NET assemblies can reach into the Win32 API and do just about anything. I mean, anything a normal binary would do. And this bridges that gap. So you take a .NET assembly, you serialize it into XML, you run it in JScript, in memory, it unpacks itself, and you get full access to the Win32 API. So whatever you want to do at this point is fully possible. This really unlocks Vbscript and JScript, and why we're starting to see some resurgence of attackers being drawn back to this. Dave, again, in his talk, talked about people looking at C#, like tools like MSBuild, .NET to JScript, VBA. There's a couple different ways to do this, but this is really a powerful capability. I want to make sure people understood what's possible here. So definitely go learn more about this. We've written a lot of payloads using .NET to JScript. How many red teamers have used this on a payload? Let's see a couple hands. Awesome. Okay.
Cool.
No DLL on disk, just an XML file that gets downloaded. Pretty fantastic. Okay, so with that, that's the background on COM, a little bit of overview. Matt's going to jump in some of the cool stuff here.
Cool, awesome. So kind of a dense topic, right? There's a lot of different processes, a lot of different things that go into COM registration and resolution. So the next few slides, we're going to go over kind of the resolution process and what that looks like from a researcher's perspective. So obviously Process Monitor from sysinternals is a really good tool to trace what's happening as far as queries, lookups, and loads. So this is just an example query of saying what COM objects does Explorer load for the user that don't exist on Windows. So that would be a lot of good COM objects that are going to get loaded that you can hijack without worrying about disrupting user functionality, without hijacking an object that the user is going to rely on, or the operating system is going to has to function with that object. If you hijack that object and something breaks, it's going to be noticeable to the user. So that's just an example query of it. This is what the output looks like. So you can see here, we talked about the various keys. So inproc server 32 is going to be one that you're going to want to pay attention to. It's the most common key that hosts the COM server, or the DLL or binary that's backing that COM object. So if you throw a DLL with the proper exports in that key, or the path to the DLL in that key, next time that object loads, it's going to call load library on your DLL. And you're going to get code execution when that happens. So that's just one of the many ways. That's kind of what a generic hijack would look like. So again, take note of the name not found, meaning that it's not there. You're not going to disrupt any existing functionality with the operating system, and you're going to get your code loaded when a user logs in, which is good persistence. So kind of the enumeration tools that we've used historically. So you've got OliView.net, which is a an expansion on Microsoft's tool that James Forshaw over at Google Project Zero has been developing. It has a very, very, very in-depth, enumeration stack as far as figuring out methods, properties, what are what objects are enumerated, are they exposed over Dcom, stuff like that. Obviously, Procmon for tracing resolution, tracing loading, RPC view, API spy to get kind of a lower level view of what's being called and how you might be able to put yourself in the middle of that. And then Cert Util. This is dumb. We all love Cert Util. Casey loves Cert Util. For whatever reason, you can enumerate all COM objects, basically whatever you want using Cert Util natively, which is cute. This is what that looks like. So you run Cert Util.class, and then the COM server you want, you can pass it a class ID, you can pass it a program ID, you can pass it really any COM registration component that you want, and it will pull down every single instance in the registry that component's registered as. So here we just use scrobj.dll, which is the COM server that backs COM scriptlets, and you can see the classes that are already registered in the operating system that utilize that COM server. So that'd be a quick way to enumerate what other monikers might be registered that use this COM server, right? So kind of a really random and obscure enumeration method, so you don't need to bring any additional tooling with you. You can just use Cert Util as it is. So kind of the malicious tactics overview. That was kind of a quick enumeration, post. You guys can go dig into the tools. I highly recommend you do it. With that said, we're going to jump into kind of the malicious implications of some of this. So persistence, lateral movement, some of the evasion as far as evading command line logging, evading app whitelisting, stuff like that. So persistence, there are a lot of posts out there now on COM hijacking and how you can be persistent on a host utilizing that technique. Obviously, it's a little stealthier, or it was until it became relatively used than the typical run key. The idea behind this is that you're taking when a user logs in, stuff happens. So Explorer loads all of these COM objects. The idea is you hijack either an existing one or a non-existing one, and you either register that COM object or that class ID as your own, or you add what's called a treat as key, which we'll talk about here in a little bit. This treat as key basically says when I go to instantiate this class ID and that key exists, it's going to point to the class ID of another object. So when Windows says, I want to load this random class ID, treat as is going to be like, well, I'm here, so now you have to go load this class ID, which gives us the ability to kind of man in the middle of the resolution process. So this is what a registry-backed custom COM object looks like. So this is what you need to throw in the registry, basically to create your own COM object. So in this instance, we've created a new COM object called Bandit. That is the program ID or the human readable identifier for that specific object. Once you've done that, you need to give that program ID a class ID. This is going to be the giant string or the giant GUID that the Windows is going to associate with that object, right? So the program ID is going to point to the class ID. So when the program ID is queried, it's going to query the class ID, and it's going to go and query the COM server. So you can see the COM server registered, the nproc server 32 key. We've set that to the COM scriptlet COM server, or the DLL that handles COM scriptlet execution. Then when you do that, fortunately, or actually weirdly enough, there's a key you can add that is associated with that COM server called scriptlet URL. And what that does is it allows you to throw in the URL of a COM scriptlet on the internet, and when that object's instantiated, it's going to execute whatever's hosted there. I can't think, I stayed up many nights trying to think of why in the world that would be a thing in Windows, but it is, and it's there, and it's really cool to use. So I highly recommend that you tinker around with it. So up to the first two arrows there, we've created our own object. We've created Bandit that runs a COM scriptlet on GitHub, right? The last two lines there are, we are hijacking the class ID that Explorer loads when the user logs in. Instead of hijacking it by actually creating the object ourselves, we're adding a tree as key, and that's saying anytime that this class ID is instantiated, I need to go and I need to actually resolve the class ID that belongs to Bandit, and it's going to proxy itself up and it's going to load our code for us instead. So kind of dense. Use that as a reference as far as, it can get really confusing once you start manually creating these keys. Things can get really wonky, so use this as a reference and definitely play around with it. And then we've got a demo. I don't do live demos. I'm not Dave.
Yeah. Mine failed this morning. Are you ready?
Yep.
Okay.
Yeah, so this is just an example, kind of very similar to the one that we just posted on the previous slide, showing that there's a Scriptlet host on the internet that's just going to start calc. This can be anything. And then we've got the treat_as key that proxies the original object to our object. So we just import that guy. User logs off. When he logs back on, these keys or these class IDs can be found using procmon. So you can set procmon to start on boot, and then you can filter down all of the objects that are loaded when a user logs in, right? So you hijack that one. There are hundreds that you can use. So user logs back on. Explorer is going to enumerate, instantiate that object, and then it's going to run our Scriptlet from the internet. So the only really things that are being changed here are the registry-backed object that we created, right? So we're not dropping a binary. We don't have to worry about app whitelisting. Is our DLL or exe going to be blocked, stuff like that. We're just executing it from the internet. Yep. So Cert Util hijacking. This is kind of very similar. So the idea of hijacking an object that a process uses, you can use that A for persistence or B for evading command line logging or things of that nature, right? So when a process starts, most processes or most binaries use COM in some manner. COM is embedded in the operating system. So Cert Util, when you start Cert Util for anything you do, it's going to query that class ID. It's going to instantiate an object that it needs to use for something. And if we had a treat_as for that ID to point to ours, anytime that you start Cert Util, it's going to load our code instead. So you're kind of seeing the implications of treat_as and how there's a lot of room for some serious abuse, as far as that goes. And it's actually happening. So when Casey and I put stuff out, we're like, yeah, this is cool. It takes, sometimes it takes a little bit for people to decode our really obscure tweets. APT28 caught on pretty quick. There was a document where they, targeted InfoSec folks pretty recently, and they were persisting using COM object hijacking, which is kind of neat to see. It also freaks me out just a tiny bit. But I try not to think about it. So it's being used. So it's definitely something that defenders you should be looking for or at least thinking about.
And I think the whole point of publishing these, tactics is so there's eyes on it. Because if we don't think we're the first ones to ever find something, we just like to bring it to light so the defenders have a chance to see it being used by other actors for sure. So.
Yeah, there are people out there and people that are using this stuff. They don't talk at security conferences, so at least exposing that so that defenders have an eye on it, is kind of our sight or our insight onto it. So kind of moving on from persistence, we're going to jump into evasion. This is going to be around app whitelisting, command line logging. I've started to see environments that implement command line logging a lot, and it freaks me out a lot as an attacker because almost everything you do is done on the command line, or it has previously. So evading all of that, obviously it's a risk-reward trade-off of you're making changes or you're doing hijacks to evade that command line logging, but you're putting yourself as an attacker in kind of a unique spot. So basically, we can hijack a COM object to load our code when something happens on the host. So the persistence techniques that we showed, we added a COM hijack for Cert Util, or we added a COM hijack for a class ID Explorer uses. When that happens, there's nothing on the command line that's showing, hey, this process started with these parameters that loaded code. The operating system is just ingesting that COM object, and due to how resolution and the OS works, it's loading the code for us without exposing any of that code to the command line. So here's a good example. This doesn't really fall into command line evasion per se. It was just a really, really funny thing that even now coding is hard. So who's seen the pub/pr and VBS command injection bug? Actors, for whatever reason, I don't think you get much out of this because that's exposed on the command line. But attackers are using this nonstop now for some reason. So basically what happens here, you can see here that we have this Microsoft signed script that exists on Windows 7, Windows 10. We're passing it a first parameter of an IP address. The script is designed to help publish printers in a domain. And then we're passing the script moniker with a COM scriptlet to the internet, which is a little weird in calc pops, and everything's hunky-dory for the attacker. I think on the next slide we've got, so this is an example. This is actually put out not too long ago, maybe a week ago, of an actor actually using this technique only instead of running it out of the existing directory, they copied it to another directory. They copied Cscript, it was either Cscript or Wscript, to program data, called it ying.exe. And this is where, like, during Dave's talk, like, that why I don't understand. Moving binaries around, binaries running out of weird locations. Why is ying.exe running out of program data? Probably not a super great thing. That binary is signed, but obviously the scripting interpreter running out of a non-standard location is a pretty big hint. They move it over, and then they run ying.exe, and then they pass it yang.txt. So ying.exe is Wscript. Yang.txt is the pubprn script. And you can see that they're passing localhost as the first parameter, and then a really ugly and very noticeable obfuscated script moniker with a com scriptlet host on the internet. That scriptlet's still up on that IP if you want to go look at it. And there's the ghost bin at the bottom that has, John Lambert did a good analysis on this specifically. So how does this work? This is the code underneath that causes that code to get executed. The script takes two arguments, server name and container, and then it passes a second argument to getObject. We talked about getObject earlier. We talked about how dangerous getObject and createObject are with monikers. So it's taking something a user supplies and then calling getObject on it, which more or less gives you arbitrary code execution if you combine a moniker with an actual com scriptlet. This isn't the only one that exists in Windows. I encourage you to go hunting. Vbscript and JScript people aren't really auditing as much as they are as far as PowerShell goes, for command injection, race conditions, stuff like that. So it's kind of a unique kind of a class of abuse, I would say. So dipping into evading command line logging. So we talked about hijacking COM objects, and as an attacker, you can do things on the operating system that would result in an object being loaded. That can be starting a process. That can be, opening a folder. Anything you really do, obviously COM is so integrated in Windows, almost everything you do is going to invoke some sort of object at some point. So there's this class example, scripting.dictionary. It's a registered existing COM object. If you want to evade command line logging, all you really need to do is hijack that object. You create your own scripting.dictionary, and instead of giving it the actual COM server it's expecting, give it, the scriptlet URL combined with the scrobij.dll COM server, and you now are, when that object's instantiated, you now have code execution. When from a forensics or from a defensive perspective, these are the things that are changed in the registry, but according to the operating system, it's just instantiating the object like it's supposed to. API calls are API calls. It's going to do its resolution. It's going to load the code up for you. And when that happens, there is nothing that's going to be exposed on the command line other than how did you instantiate scripting.dictionary. Maybe you could open, so pubprn.vbs, when you run it, it instantiates that object for you automatically. So you can get really creative with what you do to instantiate an object and then which one of those objects you hijack to get your code to execute without actually tipping to command line logging. So before we get into kind of a deep example, we talked about .NET to JScript, and you're saying you can run COM scriptlets from the internet. That's awesome. How does that really help you, since Vbscript and JScript historically you could only instantiate COM objects? With .NET to JScript, you can essentially run shellcode in Vbscript or JScript. So when we're running these COM scriptlets from the internet through hijacks or persistence or stuff like that, that's shellcode execution from the internet without having to put a file down, without having to do any weird injection, without having to do any of this crazy stuff, due to Foreshaw's work and how it's kind of expanded how we use JScript and Vbscript operationally. So, oh boy. Okay, perfect. So going back to scripting.dictionary, obviously if you hijack that object, anything that uses that object is going to break, right? Because you are hijacking its functionality to use your own logic instead of what it was designed to do. Casey figured out that you could just re-implement in your malicious COM scriptlet the methods that object expects, which are documented. If they're not documented, you can go and reverse the COM server if you feel like drinking a lot of alcohol in a short amount of time. So these methods are exposed for scripting.dictionary, and then in the COM scriptlet, you can just implement them. And functionality will return after your code executes. The scripting.dictionary methods and properties will still be available for the operating system to use, which is kind of neat. So this is just an example of a Microsoft signed script that when you run the script, it calls create object on scripting.dictionary. So we just showed how you could hijack that object. This is how you would instantiate that object. This is one example of how you would instantiate that object. Just run the script and your code's automatically loaded due to how COM resolution works when it hits the scripting.dictionary prog ID. And this is what it looks like. So nothing crazy on the command line. There's no script colon, lol.ru/com.stt. It's running and your payload runs and functionality returns back to how it should and everything's hunky-dory according to the operating system. So just kind of a fun little tip. And you can do it with almost everything, obviously, that uses COM. So this is just another script for configuring WinRM that uses the same scripting.dictionary object we hijacked. Same result. If it gets instantiated, your code's going to get loaded. It doesn't matter, how you instantiate it, as long as it gets instantiated. So a little side note, AMSI. This is actually, I reported this to Microsoft. This actually got fixed in an insider preview build, which will be pushed out, sometime in the near future. This is using COM hijacking to disrupt the anti-malware scan interface, which is responsible for, as Dave mentioned in his talk this morning, it is something that Microsoft spent a lot of time implementing to kind of safeguard or add an additional layer of protection as far as PowerShell and Windows scripting host attacks go. So it hooks at the lowest level before interpretation, and it takes this content, this de-obfuscated, unencrypted content of your malicious payload, and it submits it for a scan before it allows it to execute. And it's became a royal pain in my butt as an operator. And so, I set out to kind of see what are some ways I could get around this. We talked about how the object that Casey talked about earlier got around AMSI because it's not actually running in PowerShell. It's not being instantiated in PowerShell. This is a more aggressive approach. And so AMSI, how it works is when it does its scan, when it submits content to a scan, it actually instantiates its own COM server. So AMSI.dll has a COM component implemented. So when it says, I just got pass invoke Mimikatz, it's going to instantiate the COM server and it's going to expose scanning methods. It's going to say, I need to take this content, I need to call, scan blah on this content to see if it's legit. If you hijack the class ID of AMSI, when it goes to instantiate itself, it's going to do the resolution. It's going to see our treat as or our class ID hijack, and then we can just point it off to a non-existent DLL. Oh boy. Somebody from Microsoft in here? Anyway, so while he figures that out, it's going to instantiate that object. It's going to resolve our non-existent DLL. It's going to try to load it. And you can either get code execution when it tries to scan content, which is also pretty funny, or you can just shove it off to a non-existent binary, and it's not going to be able to call the scanning methods. So it's not going to be able to say, hey, this is legit or not, and it just lets it go. This is a good example. That pastebin link is just a test case. It's just an ICAR string that the PowerShell team put out to let people kind of play with or see how AMSI works. You can see that we're running invoke expression on this thing. It triggers AMSI. You can see at the top that it says that it contains malicious content and has been blocked by your AV provider. You can see that kind of middle block there is the COM hijack. That's a class ID for AMSI. We simply register it in the current user hive. So any medium integrity context or any normal user, when a common object's instantiated, it's going to look in the user hive first. We talked about the resolution hijacks and how that works earlier. So we just shove it off, create improc server 32, and we give it go away AMSI.dll in the root of C, which doesn't exist, right? Import that, restart PowerShell, and now you can see that when we invoke expression on the ICAR sample, AMSI is not able to instantiate the COM component. It's not able to scan it. And so it kind of fails open because that method's not available, and it lets us execute it, right? So they did fix it. They removed the call that does the actual registry lookup, so it literally loads the COM component out of System32 now, which is great. So this is just one example of operationally not just using it for persistence or command line logging evasion, but getting around security products that might rely on this kind of technology. There are a lot of other AV vendors out there that have components of their software implemented as COM servers that are very likely vulnerable to the same kind of concept. So the last kind of component here is lateral movement. I, as an operator, got really sick of using the same 4 or 5 techniques on assessments. Defenders were getting really cocky and comfortable with, oh, we know how to detect WMI, we know how to detect PSExec, we know how to do scheduled tasks and and we're good and everything. And so I went on kind of a 3-month rage research spree. And I had been looking at COM already, and so I was like, well, there's this thing called Dcom, which is the Distributed Component Object Model. And it just allows certain COM objects to be exposed remotely, which you can see how that kind of a light bulb clicked. I was like, okay. So basically, Dcom's set up so that there are machine-wide launch and activation permissions. And this determines what user or what group is able to instantiate this object remotely. Then each application, each Dcom application has specific, set security properties for itself. A lot of the more interesting ones don't have specific ones set for themselves, so they fall back to the machine-wide permissions, which allow any local administrator remote launch and activation permissions, meaning that if you're a local admin, you can use these objects remotely without really any barrier. Whoa. Okay. Alrighty. Technical difficulties. Yep, so this is just an example. It's up on my blog that you can go read about it. We'll have the slide deck up as well. Just an example of running calc on a remote host. So you can do a whole lot of different things. Office has a lot of really neat methods that allow you to run code. I blogged about most of them that you can go read there. The new one that I wanted to talk about was Outlook. We talked about create object. You can instantiate a new COM object. Outlook has a method called create object. Outlook's exposed over Dcom. Outlook doesn't have any default launch and activation permissions. You can see where I'm going with this. So we kind of have a little demo here. Basically, how this is going to work.
Just pull it up.
Yep.
We're about 1 minute left.
Alrighty, that might be perfect. So you can just see that we're a local admin that's a remote host. We're using another COM object to run Vbscript or JScript. So this can be shellcode via .NET to JScript. We're basically throwing our code, our shell code, for example, in a variable, and then we're activating Outlook that application on the remote host, right? So that's going to give us access to Outlook's methods and properties. From there, we then use that to call the application that create object method on that return Dcom handle, per se. And that's going to let us instantiate script control, which is a COM object that lets you run Vbscript or JScript on that object. We set the language to Vbscript, we pass it our code, and automatically the code that we originally put into that console or that script gets executed for us. You can see that we are on the remote host now. You can see calc.exe is running as a child of Outlook.exe, and that actually is running as the user Matt. So one thing to key off of would be a process that's not the user logged in. That process is going to be running as a different user. There are different Dcom applications that inherit the current logged on user's session, so the process won't look weird, but that specific one will stand out in that way.
Cool.
Yep.
I think just for the sake of time, I think we're out of time, so I don't think we have time for questions. So I'm going to honor the next speaker and turn over the stage. But if you have questions for us, find us on Twitter, find us in the hallway. We're around all weekend. So thank you for your time. We appreciate it.